Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Wellington. Today what we're going to be doing is taking a look at three different possible approaches to doing an app migration into Azure. We're going to be looking at the solutions architectures for those, and then thinking about how that's going to have impacts on how I move an application into Azure. So today we're going to be launching into a more lab type environment where we're going to be doing an actual app migration into Azure. I wrote a little sample app that does some pretty basic stuff, but I think it will exemplify some of the challenges that you might face when doing app migrations into Azure. So I want to use this as a lab type environment to kind of explain how the process might work and give a more practical example of what we've been talking about more in theory as we've looked at some of the tooling and things like that over the last few videos where we've been discussing a lot of these things. And then the decisions that we make concerning this particular app will impact how we plan an app migration into Azure. So the outcome of this would be something like an Azure landing zone as well as a migrated app into Azure. So today I wanted to look at the app and then talk about potential paths into Azure based on the architecture of the application and then some potential solutions architectures inside of Azure. And then that will help us determine what we're going to be doing for a landing zone, and we'll be working on setting that up over the next few videos. And I might even go into multiple different strategies to show you what those might look like as a sample based on some of the outcomes of the discussion that I'm going to be having today concerning the application. So I want to give you a brief demo of the application. It's pretty basic, but I think it will show you what I want to do with this particular app migration here. So I'm going to log into the app, and what this does is displays a gallery of images, and these are some images I took from my drone. And if I wanted to show the images, I can look at the gallery here, and it's just scrolling through the images. And if I want to show them, I click on show, and it just simply opens the image in a new tab. So there's my front yard and my backyard, I guess, too. And if I wanted to see the image in that context, I can do that from the thumbnail to a full-sized image. But at the same time, I can also print the image. Now I have this hooked up to a PDF printer, but I could hook this up to an actual printer and it would print a hard copy of this on a piece of paper or whatever media I have inside of that printer. So I'm saving it to a PDF as a PDF printer right now, and then it should save that file and then print it out. So show you that that's not smoke and mirrors. Let's just go here to this PDF and open that up. And there's the image that I was just printing there. So again, very basic application, but what it does is it shows you an application that's doing some functionality. So it's got some requirements that I need to account for. So let's go look at some of the architecture for this, and then we'll take a look at some of the implementation of this on the actual file system and the way that the code is constructed, etc., so that we can get an idea of some of the technical challenges that this application is going to have in a migration. So here's the basic architecture for this application. Now, when I just ran this, I ran it all within the context of a dev environment to show you the application running. So it's all running on a single box. However, in a production environment where I would have this running is across a bunch of different systems. So I had my client application, which was basically just a web browser running the UI front end. That's where we saw the images displayed, and then I had the buttons there. Now that was connected to a web server right here. Now the web server, of course, is doing a lot of the heavy lifting. It's what's serving up the APIs as well as the static content that the client app used, and it has an API that the client app can interact with to do the functions that we saw. That is, load the image up into a browser tab or access that data in other ways through a printer. So in a production environment, that web app then, if I click the print button, would then queue up a print job on a print server. So basically it's going to read the image data off of some storage, just like it did whenever we were serving it up as content, and then send that image data over to a print server that is connected to a physical printer to print the image. So this has a bunch of network attached type instances that I need to account for. So I have the client as a network client. This is going to be a network-based server. It could have network-based storage. It's going to have a print server involved for the actual printer that's attached to this particular application. And then that printer is then connected to the print server by some means. It could be a remote printer that is working over a network, or it could be physically connected through something like a USB cable or some other means like that. All in all, though, this is a distributed application that has a lot of different parts to it that are all bound to a network. So let's go ahead and look at the code on this just for a little bit. I'm not going to get into the details of the code to walk you through it, because that's really not the intent of this, but I do want to show you these various components and how they were reflected in the code and how they are manifested in the technical implementations that we see here. So I wrote the application I just showed you in Node.js. Now, Node.js is one of many different languages. This is really not to teach you about Node.js or anything like that, but it's to show you an example of an application that you might encounter. And even this application is not really what I consider a upstanding example of what you might experience with Node.js. In fact, there are much better examples for that online. This is really more to show you some of the things that you might encounter with legacy code or other applications that you might have running inside of an Azure migration. So this particular application has a folder that looks like this. I have a Node.js application, and it has a self-contained web server. So the web server that this uses is called Express, which is generally the main one used inside of Node.js applications. So you don't have to configure something like IaaS or Nginx or Apache to run Node.js applications usually. And so they have a shipped web server that comes along with it, and you interact with that web server using the JavaScript that you write into the application. Now, the actual code for this is pretty straightforward. It's an API, and these are the dependencies that it has. These are Node.js dependencies. This is just reading some configuration out of the environment, and this is configuring a web server. And these are some helper functions up here, and these are the APIs that I've exposed, called list image. This one's called image. This is called get a thumbnail. And this one's called print. And those are basically the 4 functions that this particular application is supporting. So nothing real revolutionary here. It's actually a pretty small application. And this application is serving up content from a static folder called public. And this is the client side application right here. So if I open this guy up, it's just HTML5 using JavaScript and Bootstrap. So these are some fairly common libraries. Well, at least Bootstrap is. I'm not really using anything like jQuery or Angular or anything like this. I'm just writing this in pure JavaScript and then using Bootstrap for the UI type stuff. And it's got a couple of functions to it. One's the print image function that goes out and gets the image, and then does a command to print that image on the back end. This one does some showing of the image. So this basically gets the image, downloads it, then opens a new tab. This one gets the thumbnail and then generates some HTML and then puts that onto the page. And this is the login function that's shared among them that basically authenticates the user. So it reads the form and then passes those variables back into the backend so that it can do authentication. Now, this all works by using an authentication mechanism that's not bound to anything like Azure AD or AD itself. It's fairly low tech, and you could do this with a database, or you could do this with the way I've done it, which is probably not the best way to do it, but it's what I wanted to do to show you something that might show you some idiosyncrasies about this particular application. So this uses a folder structure to represent the data, and it's all in this images folder. So I specify a root whenever I load this application, and it's all inside of this particular images folder. Now, every user then has a separate folder. If I wanted to have another folder called Blaze, I would have that. And inside this folder, I have different kinds of data that I'm representing. This is the images folder. That is the large uncompressed images, thumbnail images. This is what I would send off to the printer in the case that I print the image. So it's a high resolution image here. The thumbnails here are generated from those other images. So it basically gets the image. If it's requesting a thumbnail, it will then get the image and resize it to a thumbnail size and then store it in this folder. So the application on the server is first checking to see if it exists in this thumbnail folder. And if it doesn't, it goes out, grabs the main image, it creates one on the fly, stores it here, and then serves it back up to the client. And so there is a need for the ability to read and write from this folder, this thumbnails folder in particular, whenever I'm running this application. And then this is where the password is stored inside of this text file here. And this is a hash of the password. So it's basically using a text file to store a password hash. And then you have to know the password for that hash for it to work. So I'm not exactly storing these in clear text, but it's not exactly the most secure thing either. I would really consider this application maybe be something like an internal application, but I'm really showing this as more of an example of an application as a sample, not so much as something that you might want to do in a production-like environment or real live application. You'd probably want to put these into a more secure location, such as putting these into a directory or putting these into something like a database that has more controlled access than the file system here, or maybe putting some permissions around the files, whatever it might be, to make sure that these password hashes aren't just easily modified or changed in the context of the application, so that not everybody can just drop in a new one and change somebody's password. In any case, that's kind of the structure that this is going for. So let's go and look at some potential solutions for this if I wanted to migrate this into Azure. So I'm going to be looking at it from a couple of different angles. Considering the technical aspects of this, I have a couple of things just to bring back up the slide that we were looking at. Where we have the various aspects. We have the storage requirement that we have to address for the images. We have this back-end dependency on the printer that we have to account for, so we have to figure out how to make that work. And then we need something to host a web application, and then we need to make sure that the front ends can communicate with the web server, and that the web server can communicate with something on the back end that is going to invoke the print job on the printer. So these are kind of the technical requirements that I need in order to make this work. So that is going to really have a shaping effect on whatever solution architecture I choose. So let's go look at a couple of different solutions from a technical aspect, and then we'll talk about the pros and cons of those particular solutions as we walk through them. So here's the first scenario I want to talk about, and this is lift and shift. Now, lift and shift is basically where you take an application as it's hosted on-premise and you put that on Azure. In this case, I'm hosting it on a virtual machine. I have my application running on a VM, and it can run on a VM on Azure as well. Now, I could move the VM from on-premise into Azure, or I could create a marketplace VM on Azure and reinstall the application on that. In this case, given that this is a Node.js application, that's fairly straightforward, and I could probably just reinstall the application on that new VM on Azure, so I don't really have to migrate the entire virtual machine up to Azure. And so that would be a fairly straightforward lift and shift approach, and I could automate that through ARM templates and scripts for VM on Azure. Now, the storage component on Azure, I could probably use something like Azure Files to accomplish what I'm using on premise as basically a disk-based storage here. So I could use that to host those images as well as the password files and the thumbnails, and then connect that up to a VM here. And that would be a fairly straightforward solution there. And then I could just maintain that file structure and then have this read and write from it. Now, I would need a virtual machine as a host for that application that can communicate over a VPN back to on-premise because of the print jobs. I can't migrate a printer into Azure because that's in the cloud. I have to host that printer on-premise. And so I need the host for my application to be able to communicate with the print server that's controlling the printer. And so I would need something like a VPN to make sure that that traffic is able to route back to that print server on premise, but also to secure it, because I don't know the nature of that traffic, if it's secure or otherwise unsecure. So I'd want to have a VPN in place to do that. A couple of other remarks concerning this. I would also want to make sure that this is highly available. So I'd probably want to have at least 2 instances of the application running on 2 different hosts and doing a load balancing act between the 2. And I would have a load balancer involved in that, so that you would have incoming traffic from this client over here hit the load balancer, and it would get shifted among the 2. And I wrote this in a way that it's stateless, so that it doesn't require that I have anything like a session-based affinity cookie or something like that. All the state is maintained more or less by the client, so I don't have to really account for all that. So I could just simply use a simple load balancing scheme with 2 virtual machines, and that would satisfy the HA requirement. So let's talk about some of the pros and cons of this approach. Now, the pros of this is that it's very straightforward to do, because this is an on-premise application, on a VM. I could just as easily move this to Azure and migrate it that way. So it's no code changes really. It's just take it as is, move it into Azure, and it would work like that. It aligns well with existing patterns, meaning that I'm used to working with VMs. That's kind of how the assumption that the application was written under, and that's the way it's been working historically. So it basically works with what I already know, what I'm familiar with, and what I'm comfortable with. And again, there's no refactoring effort to this. There's nothing that I really have to do to refactor the application. All I need to do is configure the application in a new host, and I would be up and running. Fairly straightforward, fairly easy, nothing real fancy about that. The cons of this is that it could be more expensive on Azure, given that I have to run this on VMs. Now I have to maintain 2 virtual machines. I need to have the licensing for those virtual machines, and then I have to pay for the compute resources. Now, virtual machines can be cheap, but at the same time, cheap doesn't always mean that they're less expensive because of some of the other factors that go into maintaining and managing virtual machines in a cloud environment. So there are kind of some hidden costs associated with that. That's not always reflected in a monthly consumption bill. But even so, considering this application, I still think that this would be the most expensive hosting option, given that there are other options that I could use that would be cheaper than this one. And this one would also be more prone to outages, given that this one has a dependency on something like a VPN for those print jobs to work. Now, you can build high availability into your on-premise connectivity, but that is still prone to failure. If one goes out, you would have to have a failover scenario, and that would require redundancy in my on-premise hardware and on the Azure side, so that I can have a failover VPN in the case that my primary one goes down, and those kinds of things. So there's some additional costs associated with high availability from that as well. So there is some definite cons to this approach, but I think overall this is a very straightforward migration. It would probably be the easiest one to accomplish and the fastest one to move this application into the cloud based on what I've seen so far. So the second solution is to use containers with some minor refactoring that I think I'll have to do. I'll talk about that in just a moment. Architecturally, though, this looks very similar to what we saw with virtual machines. The only major difference here is that instead of running this directly on a VM, I have a container that is hosting the application instead. The container option opens up a lot of possibilities on Azure, ranging from something like Azure Container Instances to a full-blown Kubernetes cluster. For this one, though, I think I would probably go with Azure App Services for containers, and I would take that Node.js application, containerize it, and then run it as a container on that solution. And container applications can then access some of the storage underneath that. So I could still use Azure Files for my images, as well as the password hashes. And I can use private endpoints, so I can send that traffic back to the printer by way of a VPN. Now, I know you can host Node.js directly on Azure App Services, but I don't think I would be able to access something like Azure Files through that option. Rather, I would just simply containerize it and then mount the files from Azure Files into the container through Azure App Services for containers. And given that I can use private endpoints, I should be able to ship the traffic for the printer over a VPN and bind this to a VNet in that case as well. So that would be a great option for this. I don't really have to worry a whole lot about HA in this context, because the HA solution here is App Services, and App Services is going to give me the ability to do self-healing. And if I want to run multiple instances of this application, I could easily do that and then load balance between those and configure that environment to run this application and keep it highly available without having to have a lot of that management overhead associated with it. And given that it's a web-based application, the client should have no problem communicating with it as well. So what are some of the pros and cons of this? I think the biggest pro of this is that it's cheaper for storage and compute overall, because I don't have to have a VM installed. I don't have a lot of options that are needed for that. I just basically use App Services to host this, and overall the management costs go down, the hosting costs go down, because all of that is kind of rolled up into that monthly bill that I get for an app service instance. And I'm not paying licensing on operating systems. I'm not paying for redundancy in the compute, and a lot of the overhead for managing that is taken on by Microsoft and not by me. And so there overall total cost of ownership, I think for this one is going to be a lot better off than what I would get if I went with the lift and shift approach. There's a lot of cons associated with the container approach. It does require some refactoring. So going back to the slide that we just looked at, because this would be on a container, the refactoring effort for this would require that I do something with the print story inside of this particular container. The way it's currently written is that it's intended to run on Windows, and it's taking advantage of some of the print infrastructure on Windows for printing those images and sending them over to a print server. And I'm invoking that from the Node.js application. Now, to put this on an app service for Linux, I would have to refactor that and probably go with a Linux host because it's Node.js. That should be pretty straightforward, but I would have to use the Linux host's print services, which are cups in the Linux context. Cups is the standard that is used in the Linux space for handling print. And I would have to reconfigure the print portion of the application to interact with cups so that cups could then send the print jobs over the VPN back to the print server and then ultimately to the printer. So there's some refactoring effort that I would have to do there. I think it's fairly minor based on what research I have done. So I don't think that would be a big deal, but it's still some refactoring that I'd have to do to get that working on a container. Now, this is going to be more prone to outages for the same reasons that VMs were, because I have to deal with that infrastructure piece of a VPN and I have to have redundancy and so on there. Because I'm going to be running this probably on app services, I really don't have to worry about the HA requirements on the VMs itself, but I still have to figure out the story for the kind of redundancies that I would need for the connectivity between on-premise and the cloud in that case. And the third caveat is this is going to be running some unfamiliar technology, mostly from the perspective of using containers, because I'm going to have to containerize this application. So I'd have to learn that tech. Fortunately, I already know it, so it's not a big deal for me to do that. And it's going to have to learn the ability to print from Linux context over to a print server hosted on Windows. I'm fairly familiar with that process because I've done it before and I've configured cups to interact with Windows print servers before. So that is possible to do, but for others, it might be unfamiliar technology as well. So there is some unfamiliar context here, but overall, I don't think there's a lot of real advantages to this approach versus the cons. So of the three options, I don't believe this is the one I would probably ultimately go with. If I did migrate it, I would probably go for the first one, which is straight lift and shift, or the next one that I'm going to talk about. So solution number 3 looks like this. I have a app service that I want to use. I want to do a major refactoring on this that will modernize it. So what I want to do to modernize this application is take it away from the kind of current monolithic architecture that it's using now that's intended for VMs and on-premise, and make it more cloud oriented and make it more cloud first in the approaches and paradigms that it uses. So the client itself would probably be unchanged in this case. That's already a very modern approach, and monoliths actually have been doing this for a long time. We have been writing single page applications or web-based applications as clients on top of monoliths for probably the better part of 10 years now, but that code would probably be as is without really needing to change it at all. Now, most of the changes are going to come within the context of what happens on the Azure side with some minor changes over on premise. So I would still host this on app service as I mentioned, but unlike a container, I would not put it into a container. I would use the native Node.js hosting option on Azure App Services in that case. The trade-off for that, though, is I can't access something like Azure Files. So I'd probably need to store my data in something like Azure Blob Storage. That will require me to rewrite some of the code that uses file system access to load those images. I would probably need to use the SDKs available from Microsoft to interact with blob storage. And that's pretty easy to swap out, though. Usually swapping out file system access with blob storage is a fairly straightforward change, but it would still require that I do that, and I would have to go through the code. Anywhere it accesses files, I would have to replace that with SDK calls into blob storage in that case. Perhaps the biggest change to this is the introduction of this right here, which is an Azure Service Bus. Now, the reason I would want to do this is to get away from using something like a VPN to send print jobs over to a printer on premise. Instead, what I would do is take a print job or a request to print and send it as a message to a message queue. And then what I would do then is take the code that is currently in the application and encapsulate it into some kind of service or daemon that runs on premise that's listening to that service bus for new print jobs that come onto the queue. So basically it would read the queue and it would say, oh, there's a new print request. And then it would go out to the blob storage, pull the image data across from blob storage, and then it would send a print job over to the print server. And then the print server would then send that on to the printer itself. So that is a fairly straightforward way of doing this. And it would get me out of the business of having to maintain something like a VPN or something like that. This connection right here is brokered over TLS, and so is this one. So any TLS VPNs would essentially get the same kind of encryption technology that I would have available, whether I'm using blob storage SDKs in that, or I'm using a protocol that is brokered over TLS for connecting to Azure Service Bus in that respect. So this approach is a very modern approach that is very popular among applications in the cloud, where you have decoupling of applications, you're distributing them across various units, you're not relying heavily on infrastructure and a lot of other things like that. So this is a very attractive approach for this particular application. There are some cons, so let's go look at the pros and cons accordingly. So there's a lot of pros to this that I want to talk about. This is probably the cheapest option for hosting and storage that I could have on Azure, because putting this on app services, it means that I get a lot of inexpensive hosting options, and I can also use blob storage, which is a very inexpensive hosting for data. And so that would reduce my overall consumption significantly over something like VMs, or even something like containers that are still going to be using something like a file system to access storage and things like that. It's got better built-in support for high availability, which is a big selling point of using something like app services. I don't have to configure load balancers. I don't configure any of that kind of infrastructure. I'm going to lower my management overhead, which is a cost reduction. It's kind of a soft cost reduction, because I'm using a lot of the kind of platform as a service features where a lot of the management responsibilities are taken on by Microsoft, not by me. And one of the biggest advantages of this approach is there's no hard dependencies on infrastructure to make this work, because all the technologies in this case are cloud first, they're platform as a service. I don't even really need to create things like VNets and VPNs and binding things to network layer protocols in order for my application to run. I can get away from those hard dependencies on that kind of infrastructure to run this application. And again, that's less management overhead and less cost involved and so on related to that. So while there's a lot of pros of this, there's a lot of cons to two major cons of this, I should say. One is that there's a lot of unfamiliar technology for folks that are more customarily dealing with things like monolithic applications and VMs and that kind of thing. The unfamiliar technology could be things like Service Bus. It could be things like the app services environment and things like that that are new to folks that aren't used to programming in those paradigms. These cloud first approaches are sometimes harder to adopt whenever you're used to programming in a monolith. However, they do have a lot of advantages in that they can reduce the costs and simplify things and so on. The major downside of this is that it is a major refactoring effort on the part of development. Because this application is fairly straightforward, it's not going to be a major refactoring effort in the sense that I'm going to spend a lot of time doing this. However, if you're running this on a very complex application and you were trying to do the same approach, the level of effort is orders of magnitude more complicated than what I'm doing with this particular application here. So that could be a major cost associated with this kind of migration, even though the actual hosting of that application might be significantly cheaper. So you would have to weigh the cost of refactoring against the cost savings, ultimately what is going to be reaped by using cheaper hosting options, as well as reducing the management overhead that comes along with some of those cheaper hosting options as well. So in this approach, there is certainly some value added to it, but there's also that one major caveat of it, that it is a major refactoring effort. So these are the three options that we're going to be looking at over the next few videos. And what we're going to attempt to do is create Azure landing zones with each one of these in mind. And we're going to talk about the pros and cons of the Azure landing zone and the security implications, the governance that needs to go into all of that, as well as the actual application migration itself, which will conduct that part as well. We'll move the application into an environment. So we'll start with the lift and shift scenario, then we'll go to the container approach, and then we'll ultimately end up on the actual refactoring effort. And we'll look at the pros and cons and everything that we need to take into account for building an Azure landing zone, and then ultimately migrating the application into Azure using that particular Azure landing zone as the kind of first initial step into Azure. If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.